A great day to everyone. Today, we will present to you our laboratory experiment, and it is all about Ohm's Law. So, without further ado, here is our experiment.
Objectives for this experiment centers on Ohm's law that states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions, which voltage, resistance, and the current are given. Therefore, theoretically speaking, that current is still needed to be computed using principles of Ohm's law.
In this experiment, we used the PhET simulator to get the different values of the circuit for the 5 trials. We set a circuit and used ammeters to determine the experimental current, and on the other hand, we used voltmeters for the voltage of circuit. Then we set the battery value in the constant for all the trials and find the theoretical voltage and current.
Hello, my name is Christian Gerentillo, and this is our presentation for our laboratory experiment 4 in Ohm's law. So for this experiment, we'll be using PhET simulator again, and this time we are going to try to verify the Ohm's law principle. We created a simple circuit pathway for this experiment. We used ammeters in order to determine the current for our experiment, and we will be using voltmeter to determine the voltage in our experiment. So we decided on the value of our battery is at 69 volts throughout the whole experiment trial. And for our resistor, for the first trial, it will have a value of 8 ohms, and we'll be using voltmeter to determine the voltage of the circuit. So after placing the test probes at the ends of the resistor and turning on the switch, we get a value of 8.62 ampere for our current. For the second trial, we decided on on the value of the resistor at 19.6 ohms. And after turning on the switch, we get a value of 3.52 ampere. For our third trial, we decided on a value of 25.3 ohms, and the current is at 2.73 ampere. For our fourth trial, we decided on a value of 44 ohms, and we get a value of 1.57 ampere for our current. And for our last trial, we decided a value of 88.6 ohms for our resistor, and after turning on the switch, we get 0.78 ampere and a voltage of 69 volts. So after listing down all the value for the resistance from the PhET simulator, and after finding all the experimental current from the PhET simulator, we then listed down all the values in a Word document table. Now, for finding the theoretical voltage and theoretical current, we'll have to do simple computation. So for theoretical voltage, we just simply multiply experimental current I with resistance R. And for theoretical current, we just divide voltage with resistance. So for number one, we just multiply 8.62 amps with 8 ohms to get a value of 68.96. And for finding theoretical current, we just divide 69 volts with 8 ohms to get 8.62. And the process is the same for trials 2 to 5 in order to get the theoretical voltage and the theoretical current.
In our analysis, we noticed that the resistance and current are inversely proportional by comparing the values for both, with the highest for resistance being 88.6 with a current of 0.78 and the lowest being 8 with a current of 8.62, therefore verifying Ohm's law, a law in electricity that states that the strength of a direct current is directly proportional to the potential difference and inversely proportional to the resistance of the circuit.
As we started, we determined that the higher the voltage coming from the battery, the higher the current flowing through the wirings, implying that the voltage is directly proportional to the flowing through the wirings as shown by the voltmeter. If the voltage rises, the current rises as well, as long as there is no resistance or the resistance remains constant. Since we're using the FET simulator, the trial we conducted was provided by the Ohm's rule, which can be seen when dividing the voltage by the current to get the resistance. The higher the voltage, the higher the current, which can be regulated by the resistor we claimed.